will be saved in marks table. Now let's get started with the project. Thank you.
Hello everyone. In our previous now I can run this run.py file. To run Python file, I have to first create virtual environment. I have to first go inside my virtual environment. Now our application is ready. In our next video, we are going to host this application using EC2 instance.
Hello everyone. In this video, we'll create an IAM user. We'll first log into AWS console, then we'll create an user and attach necessary permission required to an user to complete this project. Whenever an user creates an AWS account, the first user that gets created is an IAM user. IAM user have all kind of permission into an AWS resources. It is always in good practice to create an IAM user and attach only a necessary permission required to an user. By this, we can handle and misuse that can be done with AWS resources. Let's say there is a user or a new developer that comes in your company and you attach all the permission to the user. Then he can delete the resources unknowingly or knowingly. To create an IAM user, let's go to IAM. This is an IAM dashboard. Under access management, we can see user groups, users, roles, policies, identity providers, and account settings. Whenever we have a big team and many users, we can create an user group and attach a group permission to the set of users. Let's say we have developer team, DevOps team, and data scientist team. All these teams need different level of access. Hence, I can attach a policies to the group level and assign a user to a group. For this project, we are creating only one user. Hence, we don't need to create a group. First, provide an appropriate name to an user. Since we need to provide and console access to this user, we can take care. There is a different method of creating a password, but for this, I am choosing custom password. We can take user must create a new password at next sign in. By default, user will be attached with no permissions. To attach a permission to the user, we can click on Attach Policies directly. Since we have no permission, no users as of now, we cannot copy permissions. By default, AWS has provided nearly 1170 permissions. We can also create our own permission and attach that permission to an user. To complete this project, we need all this permission to the user. That is EC2, DynamoDB, Lambda, S3, Glue, CloudWatch, S3, SNS, and Athena. We should always provide fine-grained access to the user. For example, a user needs create EC2 permissions and SSH permissions. We should attach only those permissions to an user. But for this demo purpose, I am attaching full access to EC2, DynamoDB, Lambda, and all. To do that, let's search EC2. Next, let's search Dynamo. Lambda, S3, glue SNS, CloudWatch and Athena. Since the CloudWatch logs is coming from EC2 instance, I can provide CloudWatch actions EC2 access. I can also provide evidently full access. Athena. Now we have already attached all the permission policies required for this project. We can also set a permission boundary. This will help us to control a maximum permission for this user. Let's say we have attached permission policies as administrator full access, but in permission boundary we can attach full S3 access only. What this will do is it will allow user to access only S3 bucket and not give access to any other resources except for that. Permission boundary defines a maximal permission that the user can take. We can check here all the permission that we have attached. Except for this permission, IAM has provided IAM user change password policy. This is because we have ticked on the option to create a new password when user logs in. I can also attach a necessary tag here and a value. Now I can click on create user. Now our user is created. I can copy this console sign-in URL and log out from this account. I can change the password here. Now I can see that I am able to log in into my user. I can see project IAM. I can choose a necessary region from here. For this project, I'll be using Northern Virginia. I can see that cost, usage, application, all these permissions are denied only because we have provided specific permission to the specific resources to the user. Hence, these all permissions are denied. From our next video, we will start setting up our project in EC2, DynamoDB and so on. Stay tuned, like, comment and subscribe. Thank you. Hello everyone. In this video, we're gonna host our Flask application in an EC2 instance. I have already documented everything in GitHub repository. I will be attaching the link in the description. Let's first go ahead and launch an EC2 instance. Let's select EC2. Click on Launch Instance. Provide an appropriate name for the EC2 instance. Choose an appropriate AMI. For this project, I will be choosing Ubuntu AMI. Select the appropriate variant of Ubuntu. I am selecting the free tier eligible Ubuntu Server 22.04 TLS. Select the appropriate instance type. T2 Nano is smallest, T2 Micro, T2 Small. T2 Micro is free tier eligible, hence I am choosing T2 Micro for this project. Click on Create a new key pair. Your key pair will be automatically downloaded. It will help us to connect to EC2 instance using SSH. Since we have to host an application and we have to do a HTTP request on that, so I have to allow HTTPS and HTTP traffic to our server. Now I can click on Launch Instance. Our instance is launched and it is in pending state as of now. It will take some time to be in running state. Now our EC2 instance is in running state. We can check the details of the instance here. We can see the instance ID, IPv4 public and private address. We can copy this and run this. We can see that the site cannot be reached as of now because we have not enabled Nginx server as of now. There are two methods of connecting to EC2 instance. One is SSH client, another is EC2 instance connect. To connect using SSH client, we have to first go to the directory where our PEM file is present. Now I can copy this command and paste it here. It shows permission denied. To allow the permission, we have to run this command. Now run the same command here. Now I can see that I am connected to EC2 instance. Another way of connecting to EC2 instance is EC2 instance connect. For this demonstration, I will be using EC2 instance connect. Now I am connected to my EC2 instance. First, I have to install a virtual environment. Before doing that, let's update an package manager. Now let's install a virtual environment. In step 2, we have to set up a virtual environment. We are creating a project directory. Then we are creating a virtual environment name venv. This command is used to activate a virtual environment. Let's copy this. Now we are inside our virtual environment. We have to install Flask and Unicorn. Pip is a package manager that will help us to install and package libraries. Now we have to clone our GitHub repository. This will help us to copy this code inside our EC2 instance. Now I can go inside DE project. I have to copy this file inside the project directory. Now I can go back to my project directory. Now I can see that all my required files are there inside my project directory. Now next step is to run a Flask application. The file is named as run.py. Now I can see that it is running well. This is running in a local host, hence we cannot access this using this public IP. So I have to make use of Unicorn and Nginx to get this into our public IP. Since we have already installed an Unicorn, we have to tell Unicorn that we have to run app in port 8000. Now we can see that in localhost 8000 our Flask application is running. Next step is to manage Unicorn so that our server gets to know that Unicorn is running every time the EC2 instance restarts or boots. This is a description, and here we can come. Our user is Ubuntu, our group is www.data. Here we are providing a working directory that is our project folder. And this is an executable file that we have written just now. That is, it points to Unicorn and tells in localhost 8000 run the application. Next step is to enable a Unicorn service. We'll first reload a daemon service, then we'll start a project, then we have to enable a project. Now we can see that our project is created. Next step is to run an Nginx server. Here we are installing an Nginx server. Next step is to start Nginx. Now to enable Nginx to run automatically after system reboot, we have to do some configuration. We can configure Nginx by editing a default configuration in the file, specifying the upstream server, unicorn, and the location of proxy request. I can copy this code and put this just below default. Next step is to copy the location and put this in location part. Now I can exit, and our last step is to restart an Nginx server. Now our project is ready and our Flask application is hosted in EC2 instance. Now I can go to EC2 instance and get a public IP. I can copy this and paste it in a browser. Now we can see that our form is available in an EC2 instance. Thank you. Hello everyone. In this video, we'll create our DynamoDB table. Then we'll set up a partition and sort key for our table, and we'll configure DynamoDB stream. Then we'll be creating our S3 bucket, and we'll be adding staging and data warehouse layer in our bucket. This is the form that we have created in our previous video. From this form, we'll be saving the data in our two tables, that is student and marks table. Student table will consist of details like ID, name, class, created date. Marks table will consist of detail of student ID, subject, math, English, science, computer, and created date. Student ID is a primary key for marks table, and it will act as a foreign key for the ID of student. Let's go ahead and create DynamoDB tables. DynamoDB is a fast and flexible NoSQL database service for any scale. It is fully managed key value pair database. It delivers a single digit millisecond performance at any scale. Since DynamoDB is a NoSQL based database, we do not need to define a predefined schema. In this table, we only need to provide partition key and a sort key. Our table name is student. In DynamoDB, partition key is used to distribute data across multiple partitions for scalability. The sort key is optional, and when used, it helps with organizing items with the same partition key. For this table, ID is a partition key, and we do not require a sort key. Partition key determines the partition where the item is stored. It's a single attribute. Whereas sort key organizes items with the same partition key value. It allows for efficient querying of data within a partition. This is the table setting for this table. We can configure this table once it is created. By default, our provision read capacity is 5 RCO and provision write capacity is 5 WCO. When we get lots and lots of traffic, we can change this capacity mode to on demand or provisioned and provision our read capacity and write capacity accordingly. By default, auto scaling is turned on. I can also provide a tag if I need to for this table. Now I can go and create table. As of now, the status is checking. It will take some time for the table to get started. Let's go ahead and create another table. The table name is marks. Student ID and subject is a primary key for this table. That basically means student ID is a partition key and subject is a sort key. It is not actually subject, I have written it wrong, it is class. Default setting is same for this table as well. I can go ahead and create table. I can see that our student table is active. I can go and add an item to this table. I can see that only our ID table is compulsory, otherwise we can add any other number of columns. Let's say I write ID 123. The available data types are string, number, boolean, binary, null, string set, number set. Now I can go ahead and create item. I can see that my item is created. Now let's go ahead and create a DynamoDB stream. To create a DynamoDB stream, we can go to export and stream. We can also set up Kinesis data stream, but for this project, we'll be making use of DynamoDB stream. To enable a stream, I can turn on the stream. There are 4 view types available with DynamoDB stream. One is key attribute only. When any changes or insert is made on a DynamoDB table, only the changed row will be passed as a stream. When you do new image, only a new image will be passed. When you click on old image, the old row will be passed. But if I provide new and old image, it will pass a dictionary which has a key as new, and the whole new row will be passed, and other key will be old, and whole old row will be passed. That is combined new and old. Now I can click on turn on stream. Now our stream is enabled. After our stream is enabled, we need to trigger some function so that computation is made on that stream or that row. For our project, this is a DynamoDB table. Whenever a changes or insert will be done on DynamoDB, it should trigger a Lambda function. We'll be setting up our Lambda function in our next video, wherein we'll be creating a trigger, and that will trigger a created Lambda function. And after the Lambda function is executed, it will save the data in a S3 bucket. For now, let's go ahead and create a S3 bucket. This is a S3 dashboard. To create a bucket, let's click S3 bucket. I can see that S3 bucket is global. That means the bucket name will be unique throughout AWS regions. But data will be stored in a particular region in a data center. Object ownership is ACL disabled as of now. As of now, we are doing a block public access. Bucket versioning is disabled. We can also enable a bucket versioning, but that will increase the cost. There are three types of encryption, and default encryption is SSE S3, that is server-side encryption with Amazon S3 managed keys. Other two type of encryption is S3 KMS, DSSE KMS. KMS is little advanced version of encryption, wherein more security is provided to the data. I can go ahead and create bucket. Now that is our bucket is created. We can create another bucket for a warehouse layer, but for this project I am using one bucket for both staging and warehouse. I am creating a folder called staging and warehouse. Now what it will do is, whenever DynamoDB sends streams to our Lambda, Lambda will do a basic computation and save the data in S3 staging bucket, that is staging folder. After that, our glue job will run, and glue job will take a data present in S3 staging layer, and it will insert into a S3 warehouse layer. That's why we have created two folders named staging and warehouse. Now in our next video, we'll be creating a Lambda function and we'll be integrating with DynamoDB triggers. Thank you. Let's create a Lambda function that will take a data from DynamoDB table and store it into a S3 bucket. We have already created a table in DynamoDB. Now we'll set up a trigger in DynamoDB table which will call a Lambda function for computation purpose. After the computation is done, it will store a data in S3 staging layer. Let's go to Lambda. To create a function, click on Create Function. AWS Lambda is a serverless computing service provided by AWS. Users of AWS Lambda create functions or applications written in one or more supported language. The runtime provided by AWS Lambdas are .NET, Go, Java, Node.js, Python, and Ruby. For this project, we'll be using Python 3.9. Let's provide the appropriate function name. For an architecture, let's choose ARM64. Now let's create a function. This is a function that is created. A Lambda function can perform any kind of computing task from serving web pages, processing stream of data, to calling APIs. It is a serverless computing framework. We can see that there is a function named Lambda handler. It is a starting point of a Lambda function. We can change the name of the calling function here. Let's print Lambda invoked, and let's deploy it. We can test the application by clicking on test. This is the event that will be passed. In this project, we'll be passing this event from DynamoDB table. When you invoke, we can see that response is there. Let's now set up a DynamoDB trigger. Let's set up a trigger for student table. Since we are not working with a real-world example, real-world website, let's set up a batch size as 1. We can set up a starting point as latest or trim origin. Let's add. We can see that there is a permission related error. We need to grant the appropriate permission to our Lambda function that will help it to take a data from DynamoDB stream. To add permission, let's go to configuration and permission. Let's attach a policy. We can click on add permission and attach policies. Our Lambda function needs access to DynamoDB. Now we can go ahead in this table and click on add. Now we can see that a trigger is successfully added. Now we can go to our DynamoDB table . We can add an item here and we'll be able to check whether the function is called or not by using CloudWatch logs. First, we need to integrate CloudWatch with Lambda table. To do that, let's go to configuration. Let's go to monitoring and environment tools. Herein, we have something called additional monitoring tools. We can edit and enable CloudWatch Lambda insights. This will automatically integrate our Lambda function with DynamoDB. It will automatically integrate our Lambda function with the CloudWatch. Now we can go to DynamoDB. We can click create item. To check whether the function ran or not, we can go to monitor and we can click on view CloudWatch logs. We can see that a log is created. And we can see that Lambda invo is printed here. So we are successfully able to set up a DynamoDB trigger with our Lambda function. Now let's go ahead and create a Lambda function that will take a data from DynamoDB trigger and store it into a staging layer. I have already written the code. I'll attach the code in a description section. I have written a Lambda handler. We have two things, event and context. Event is something that will be passed from DynamoDB trigger. When we set up a DynamoDB trigger, we can know that it has passed new and old image. It will also pass whether it is insert event, modify or remove event. If it is insert event, we will create a data frame and we'll type event name as insert, and we'll attach all the columns and data into a data frame and it will return back. If it is a modify event, that basically means we have to remove the old entry from data warehouse and attach a new entry inside our data warehouse. Hence, it will create two entries in a data frame. It will populate the same entry with insert and same entry with remove. That basically means remove this from our data warehouse and store this inside a data warehouse. If it is a remove event, it will basically attach and put the event type as remove. Once we get the DFF, we attach a created date which will also be passed from DynamoDB. Now we can convert this into a Parquet format with compression as gzip. It will help us to further compress our data. And we'll store that into a project de date with data, and the key is staging. Inside this bucket, we have created a folder called staging. And we'll upload this into s3.upload file. For this, we'll be using a library called pandas, boto3 and datetime. So let's copy this code. Stop it here. We can deploy. Let's now test it. We are getting an error saying no module called pandas. Lambda function by default does not consider a library like pandas, datetime and boto3. Hence, we need to provide a libraries inside Lambda layers. To create a layer files, I have already put up a necessary steps in GitHub repo. Let's open a terminal. Let's open a new terminal. Let's go to desktop. Let's create a folder called Lambda layer. Now we can install required dependency using pip install. Now we can see that the above code have downloaded all the required dependencies. We can see NumPy, Pandas, PyTZ, Boto3. Now let's zip this folder. Now we have successfully created a zip file. Let's go to Lambda function and add a layer. We need to add a layer. Go on create layer. Let's provide appropriate layer name. Now we can upload a file. It's in desktop. The compatible type is ARM64. Remember, we have selected this by creating a Lambda function as well. Compatible runtime is 3.9. I can now create. It is taking some time to create a layer. Lambda layer basically takes all the dependencies and put it into a Lambda environment. Now that my layer is created, I can go to my Lambda function and attach this layer. I can click on layers. I can click add layer, custom layer. The version is 1. I also need to attach the SDK. It says the size is greater than this many bytes, so we cannot attach. I guess it must not be needed. We can see that still no module named pandas. We can go to layers. We don't need this layer. Instead, we can add a layer. Now I can add. We are not able to add the layer because of the other layer that got automatically added. Now if I hit on test, I can see that it is giving me a key error because records is not present. As of now, we just passed some dummy dictionary, hence it is giving us an error, but the error called import pandas and import datetime is removed. When it will be automatically triggered from DynamoDB, all this error will be removed. Now let's go ahead and insert a new entry in DynamoDB and check whether it is able to insert the data into staging layer or not. Now we can go to Lambda. Let's go to monitor. We can see that it has successfully processed the record. Let's go to S3. Let's go to our bucket, staging layer. We can see that student folder is automatically created. And we can see that records have been uploaded in staging layer of student table. Let's go and do the same for marks table. Now we have successfully added a trigger for marks table as well. Let's put a student ID as 7673. Math, science, computer. I can also see the JSON view as well. Now I can go to create item. Let's create one more item. Let's provide student ID as let's go to create item. Let's create one more student. Let's add the marks for Deepak. To 148. Let's go on create item. Now let's go to S3 bucket and see whether marks is present or not. I can see that marks folder is automatically populated and data is present inside marks table. Now we have successfully integrated our AWS Lambda that will take a data from DynamoDB stream and put it into staging layer. In our next video, we are going to create AWS glue that will take a data from staging layer and put it into a warehouse bucket. That will be our ETL pipeline. Thank you.
Everyone, in our last video, we have set up a Lambda function which will take a data from DynamoDB trigger and save it into a staging layer of S3 bucket. In this video, we are gonna make use of glue job and create our data pipeline that will take data from S3 bucket, joins it and saves it into a data warehouse. To do this, let's go to AWS Glue. Let's go to ETL jobs. Let's click on script editor. We'll use a Spark engine. We'll start fresh. I have already written the code for the job. We'll go through the code first. In the beginning, we import all the variables. Then we initialize our bucket name, that is project DE, date with data, and prefix is warehouse. Boto3 is used to access the data of S3 from Glue. This is a function that we have written for union. We'll understand it later. In the beginning, we start our initialization of our Glue job parameters. Then this is job.enable metrics. This is where we enable Glue job to write in CloudWatch metrics. Now we start reading our data. First, we read data from mark table in staging layer. It goes to staging, goes inside mark and reads all the file. We have provided recurse is equals to true because we have many files with the same schema inside this folder. Then in the same way, we read data present inside student folder. Date with data, staging, and student, recurse equals to true. This print statement will help us to track or debug the code in our CloudWatch. Next, we read data from data warehouse. As of now, our data warehouse will be empty. But when we keep implementing this process in a real time, we will have data in a data warehouse. In that case, what we need to do is we take from data warehouse, we take data from our staging layer, we combine the data present in our staging layer, that is marks and student table, then we union or merge with the data warehouse table. Then we delete all the old entries that is present in our data warehouse. Like that, we'll have a fresh data every time in our data warehouse. Now let's go ahead and join our mark and student table. This is where we join, and our key to join is student ID from mark table and ID from our student table. Now our join is successful. After our join is made, now we need to union our join output and our data warehouse data. We need to join union equals to all, and we call this function Spark Union. We go up, this is Spark Union function. So it need to handle one more scenario, that is in the first time when our data warehouse is empty. So for that, we have written if it is empty, then normally take data whatever is there in data in our staging layer and put it into data warehouse. Otherwise, do union for both the data. That is all. Now our union is successful. Our next step is delete all the entries that is present in our data warehouse. That will help us to remove the stale data. Next, we save our union output in our data warehouse. That way we'll have fresh data every time in our data warehouse. Now let's copy this code and paste it into script editor. Now try to save the code. Let's give the name as glue job. We need to provide a job details as well. We have to create a IAM role for now. We don't have any IAM role available as of now. Let's duplicate it. Let's search for IAM. We need to create a roles. Let's click on create role. We have to create a role for the same AWS account. So I just say AWS service, and the service I am using is glue. For this project, we need S3 access, CloudWatch access, that's all. But as of now, I am just giving administrator access. It is not a good practice to give administrator access, but just for a demonstration purpose, I'm giving it. Let's click on next. Let's provide the role name as project DE, date with data. Let's create the role. Our role is successfully created. Now when I go to job and I refresh it, now I can see it is available. We are using a worker node as G1X. There are two types of worker node available. It has 4 vCPU and 16 GB RAM. Since our data size is very small, this must be enough. So this is number of worker node, that is how many nodes will be there for parallel execution. Since our data size is very low, let's keep it 2 as of now. When our data size is in TBs or in GBs, we can make use of 10-20 worker nodes. Number of retries. If our job fails, how many times it will retry? That is what. As of now, let's keep it 0. Let's save the job. Now we have successfully saved the job. Let's go ahead and run. Our job run have started. We can click on runs and we can see that it is running. Now we can see input by arguments. These are some of the input argument that is passed. That is enable metrics, that is CloudWatch metrics, job insight, and everything is there. Now this is a continuous logs. It is still taking time to generate logs because as of now just worker node is getting allocated. So in some time you will be able to see the logs here. Yeah, our worker node is available, allocated. Now it will start job run. We can also see the metrics as here. Now since the job will be very small, like it will be get over in 2-3 minutes, so we may not be able to see lots of metrics here, but we can see the metrics if we are running a big job here. And this is a Spark UI. It will take some time to generate a Spark UI. Since our data size is small, we may not be able to see lots of data in a Spark UI, but if you are running a big job that takes somewhere 10-15 minutes or an hour, in that case we'll be able to see. Once the job is done successfully, I resume the video. Now our job have been run successfully. It has taken around 1 minute and 12 seconds to complete this job. We can track the details of our job runs here. We can see our job status is succeeded. We can see the CloudWatch logs also here. If we have got any error, we can see the error logs. Since we have not got any error, I can just click on output logs. This is the log stream that have been generated out of our job. I can click on this. These are all the details that we have printed when we are running the job. That is read mark data, read student data, then our read warehouse have happened, then our join of mark and student had happened, then union of the joined data and data warehouse have happened, then we have deleted all the data from data warehouse, then we have saved the data. So log stream will help us to keep track where we have got an error when we are running a ETL job. So it is very important to enable CloudWatch and print appropriate logs in our CloudWatch. So we can also see our input arguments, our run insights as well, or our metrics. So there is no metrics available because our run have been very small, that is of only 1 minute. If you have a big data, we will be able to see it. Now we have something called schedules as well. Now we have to run our job manually.
We can also create a schedule that will help us to run our job once in a day or every hourly or weekly and all. In this project, this is a student form where teacher can upload marks of the student and the details of the student. So hence in this case running a job daily will be enough. So let's go and create schedule. Let's give an appropriate name to this schedule. Frequency of this schedule can be daily, hourly, weekly as per our choice, but let's keep it daily. So our schedule have been successfully activated. I can see that the schedule runs every day at 12 am. So this is how we can automate our AWS pipeline. Now there is something called version control as well. Now this code may be modified by lots of people, so we can also version control using lots of services like Git, GitHub and other things. I'll put a separate video where we can learn about version controlling in AWS Glue, but as of now we are not using any version control tool. We have successfully taken our data from staging layer to warehouse layer. In our next video, we'll be making use of AWS Glue crawler and AWS Athena to query this data in a real time. This will help business analyst or data scientist to make the business decision or create ML models. Thank you. Hello everyone. We have successfully created AWS Glue ETL pipeline. Now it's a time for us to make use of AWS Athena that will help us to query a data present in data warehouse using SQL-like syntax. To do that, we have to first run Glue crawler, which will help us to create table and databases. Then we'll be moving to AWS Athena, which will allow us to query a data from the table and database created by AWS Glue crawler. So we have already created a syntax layer. Now it's a time to run a Glue crawler that will help us to query and make use of AWS Athena. Let's go to AWS. Let's go to AWS Glue. Let's go to crawlers and let's create crawler. Let's give it a name project. We can also add a description. Let's go to next. Let's add a data source. Our data source is a warehouse. Location of S3 in this account. So there is a crawler runs. We can run all subfolders, that is, we can run all the data or all the folders that are present inside the warehouse directory. Crawl new subfolders only. This is like if you are running a crawler again, then we can only run on the new data that have come into a warehouse, or crawl based on the events. Let's say I want to crawl every 1 hour, or like let's say if there is something that is put in our S3 bucket, then only crawl. So that is crawl based on event. For this project, let's crawl all subfolder. Now add an S3 data source is done. Let's go to next. Now we have to define an IAM role. We have already created an IAM role when we have make use of AWS Glue to create a data pipeline. We can make use of same IAM role because we have provided the administrator access to AWS Glue there. Lake formation is optional. Let's go to next. Now we don't have any database as of now. Let's duplicate this. Let's go to AWS Glue. Let's go to database. Let's create a database named DW. Let's create database. Now our database is created. Now let's go to our crawlers, hit refresh, and we can see that our database is still created. We can provide a prefix here, that is, let's say date with data underscore. Now we can schedule a frequency of our crawler the way we have scheduled our glue job, like daily, weekly, monthly. For this project I'm gonna schedule on demand, but we can schedule it hourly, daily, or weekly. It will create a cron job that will trigger the crawler once every day, or weekly, or monthly. Let's go on demand. Let's go to next. Now this is a review page. Now our crawler is created. So what crawler basically does is, it will go through all the data and it will try to fetch the schema out of it. It will try to analyze what's the schema of the data, and will automatically populate a table for the database in which a crawler is created. So it makes a life of data engineer easy. We don't need to manually define a schema. And after a crawler have successfully created a schema, we can tweak around. Let's say the crawler was unable to find out it's a double type and it just said it's a string, but we know it is double, so we can manually change data type. Now let's go ahead and hit run crawler. Our crawler job have started. We can go here and monitor. It's running. It will take some time to run a crawler. We can see in our warehouse we have two data that is in Parquet format. Why there is two data? The reason is we have created a two worker node, hence we have two data, and we can see that data is equally distributed. It is very important to data to be equally distributed across all the worker node to have efficiency in our job. It is taking some time to run the crawler. We can see that our crawler have run successfully and it have taken 53 seconds. Now we can go to tables. We can see that a new table have been populated. Let's go here, and we can see the input and output format. They are both Parquet format, and we can see the schema of the table. We can see event type, created date should have been removed before adding it into the table, but as of now let's leave it. We should have also removed event type and all. Okay. Now once our table is successfully created, we can go to AWS Athena. Now, once we go to AWS Athena, we will ended up in this page. We can just go on query. We can just go on analyze your data using PySpark and Spark SQL. We can just go on query. We can just cancel that. We can go here. Now we can see that we have default sources AWS setup catalog. That is the only source we have, and our data warehouse DW. We can see that our table is automatically populated, that is DWD warehouse. Do that. So we can see that the data of the student is populated. So we need to find out which student have got a highest mark. To do that, we can just sum the marks of computer, math, and science. So select student ID. We have ID. then we have name, computer plus science. We can see that we are also getting a hint, plus math as total math. From our table name is NDL warehouse. So we are getting some error. So this error is coming because if you go to the schema of the math and computer is string. So to solve this issue, we can go to here. We can cast this as you can do it. Now if I just try to do that, relax. So I run it. Now I can see that we are successfully able to cast it. Same way I can just now add cast math as int plus cast science as int as total marks. Now what we can do, we can just order by total marks DES. Now if you are doing this, we can see that Saurav is a topper of the class. So using AWS Athena have made it very easy for business analysts and data scientists to query a data present in a warehouse using SQL-like query. Just what you have to do is go and run a glue crawler. That's all. So with this, we have completed our project wherein we have implemented a data engineering solution end to end. Thank you. Do like, comment and subscribe.